Now I'm recording it. Okay, it continued when I stopped, which means it says stop, continue. Yes, it's continued. So now, when we're gonna say u of p n is going to be equals to sum, which is going to be n sum of I, because I'm using the letter I equals to 1, whereby we're gonna say it's 1 over n. This 1 over n is coming in the change of x. So change of x equals to 1 over n. So normally it says change of x f of xi minus. So here we're going to say 1 over n. When we use for the upper, we substitute this one. So we're going to substitute again. We will say I minus 1 squared. We can just say I minus 1. There is no need for me to put these brackets. I minus 1 squared divided by n squared. So now after this one, we're gonna simplify. This is going to be the same as 1 over n cubic. We multiply this n times n squared is going to give us 1 over n cubic. We take it out of the sigma notation. Then it's going to be after sum of n into I equals to 1 of 1 I minus 1 squared. So now in order for us to get this solution properly, you will see that this equation, we can rewrite it as 1 over n cubic of n sum of I, which is equal to 1. Then we can just simplify this equation. So when you simplify that I minus 1 squared, it's going to be 1 I squared minus 2 I plus 1. So now, according to this, we can rewrite this as, this is the same as 1 over n cubic. We can now put a square brackets so that we can see. We multiply it, each and every one here, we're going to have n sum of I equal to 1 of I squared and minus 2. You take out minus 2, you can say n sum of I equal to 1 of I, then plus I, even if you take 1 there, it's the same as n sum of what I. This is sum. Then take out that 1, 2, n sum of I equal to 1. Then when we have done this way, I'm gonna show you the mean, what is equals to the n sum of I equals to 1. I will just write it inside. Is the same as of I squared is equal to n in brackets n plus 1 in brackets 2n plus 1 is 2n plus 1. Yes, it's 2n plus 1 over, it's over 6. Eh? And also n sum of I equals to 1 of I is the same as equals to n in brackets n plus 1 over 2. And n sum of I equals to 1, just like this, is the same as equals to n. So now we're going to substitute this, whatever that I've just written here, into the equation. We're going to proceed with our equation. So let's proceed. So when we proceed to this equation, you will see that we're going to say we have equals to 1 over n cubic, which this one here we're going to substitute with that value there, is going to be n in brackets n plus 1. The answer here in this question, you must get 1 over 3 2n according to your memory. So if we don't get 1 over 3, it means that we are doing it wrong. There is something that we didn't do it perfect. So it's going to be n, we substitute, it's going to be that. Then minus 2, we're going to substitute in brackets. Then our I is going to be n, in brackets, n plus 1 over 2. Then minus plus, multiply this 1 times 1, we're just going to write n. So now when we have written that, we can now multiply everything by n. 1 over n cubic is going to be this n, it will cancel here. You will be left with n plus 1 over 2n plus 1 over 6n squared, because the other one, this n cancelled with this 1 over n cubic. Then minus, you will see that this one will cancel with this one here. And when we multiply back with 1 over n cubic, it's going to cancel again. We're going to be left with n plus 1 over n squared. Then plus, this n will cancel with 1 of that. We're going to be left with 1 over n squared. So now when we're left with 1 over n squared, you can now simplify, not simplify. You can now just, let's say, like, to simplify is, we can simplify this. We can write it as n squared, 6n squared there. So this one here, you will see that you're going to have n plus 1 in brackets 2n plus 1. When we say 6n divided by 6n squared, divide by 6n squared. Then minus, then we're going to say 6 is going to cut, will be left with 6 in brackets n plus 1. Then again, that is going to be plus 6. So if we simplify it, we will see that we get, this is going to be, you can simplify what is inside there is going to be x n squared 2 n squared plus n. This one times this is n. 1 times 2n is 2n, which is going to give us 3n plus 1. Then minus 6n, minus 6 plus 6. So we'll see that this will cancel with this 1 over 6n squared. Then 6n and 3n, the answer will be minus 3n. So we can just write this as equals to 2n squared minus 3n plus 1 over 6n squared. So I'm not going to factorize this. I'm just going to leave it as it is. So we're going to come back to this one. So now we have found that we have managed to calculate the u of Pn. So now we are going to calculate the lower one, L of Pn. When we calculate the L of Pn, so L of Pn is going to be equal to n sum of I equals to 1, when 1 over n in f, let me not write f of, because we know the answer. So the answer that we got there was I squared dot I squared over n squared. So now when we have this one, is more simpler, because we're just going to have 1 over n cubic multiplied by these 2 and sum of I, which is equals to 1 over I squared. So when we have this one here, we're going to say, we already know that this equation is n plus 1 over something. Then you can just say is equal to 1 over n cubic. We already proved it to you that in brackets n plus 1 over 2n plus 1 over 2 over 6. So this will cancel a little bit with this one. Then you're going to be left with n plus 1 over 2n plus 1 divide by 6n squared. So now you have that. When you have this one here, we just proved, if you want to continue, you can just, let's say, for example, so that maybe you can just multiply this times this, it's going to give you 2n squared. This one times that is going to give you minus, no, 2n squared, and then n, then it's going to be plus 3n plus 1 over 6n squared. So we have gotten that so now we have L of that and U of Pn and L of Pn. So we are going to calculate the limit. So when we calculate the limit, we're going to say limit when n approaches infinity of U of Pn is going to be equal to limit when n approaches infinity of U of Pn. U of Pn, we found that is equal to, let's check it. Yes, is 2n squared minus 3n plus 1 over 6n squared. So we are going to find a limit when n 2n squared minus 3n plus 1 over 6n squared. So are you properly seeing the screen now?
Yes, I see everything.
Okay, no problem. Therefore, now when we do this one, the rule still applies. Because we have n squared, we are going to divide everything by n squared. Then it's going to be limit when n approaches infinity of, when we divide by n squared, then we're going to have 2 minus, you divide this one by n squared, you're going to have 3 over n. We divide this one by n squared is going to be minus 1 over n squared over 6 over 6. So we know that limit when n approaches infinity of 1 over n is equals to 0. So we are going to say this is the same as equals to 2 minus 0 plus 0 over 6. Therefore, 2 over 6 is this equals to 1 over 3. So we got that we have 1 over 3. Then we're gonna prove again the limit. We just proved a limit when of what of p, u of p of n. Then we are going to prove again the limit when n approaches infinity of L of Pn. L of Pn. So the limit when this one approaches infinity of L of Pn is going to be equal to is going to be equals to 2n squared plus 3n plus 1 over 6n squared. So the same rules applies. Then we're going to divide everything by n squared. This is going to be equal to limit when n approaches infinity. When you copy exactly the way I'm writing here, you must write it exactly the way I am writing with you now. Going to be limit when you divide by n squared, we will have 2 plus 3 over n plus 1 over n squared over 6. So now this is going to be equal to, we write the final answer is going to be 2 plus 0 plus 0 over 6, which is equal to 2 over 6, which is the same as 1 over 3. Therefore, the question, let's go back a little bit to the question. The question says find the UL. We found the UL and we also find the LP. And then of P with respect to Pn. We have done that. Using the sum, using the Riemann sum, prove that f is Riemann integrable on 0 to 1. Therefore, now we just show that the limit. Now what the last step, that the second step that we are going to do, we are going to say since L of P limit, or we can say, let me just erase, or we can say since limit when n approaches infinity of u of L of Pn is equals to limit when n approaches infinity of what, of L of P n, which is equal to 1 over 3. Therefore, f is integrable on the interval one. So we're gonna go back again to the same question. So the same question says, and compute the integral 0 to 1 of x squared dx using the Riemann sums. So when we are going to use the Riemann sums to compute this, we found that the limits, we found that is equals to 1 over 3. So now when you compute that, you are going to say 0 to 1 of x squared 0 to 1 of x squared dx is going to be equals to limit when n approaches infinity of L of Pn, which is going to be equals to limit again when n approaches infinity of u of Pn, which is equal to what? 1 over 3. So you have just showed, so the integral of this when you start from 0 to 1, because 0 to 1 is the same as the partition Pn, because our partition is started from 0 to 1. So it's the same as the integral. The limits that we calculated now using this is the same, is equals to your integral. So the integral is equal to that. So here you end your proof. When I say you end your proof, you stop here, you don't show anything. This is the end of that question. So I will just show you something, just that is the same. When we integrate normally in calculus, x squared dx, you will see that this is going to be the same as, when we integrate, this one is going to be x cubic over 3 from 0 to 1. So when we substitute 1, this is a definite, we call it a definite integral. Definite integral. So in this definite integral, you will see that we have 1. If we substitute 1 here, it's going to be 1 cubic over 3 minus 0 cubic over 0 over 3, which is going to be equals to 1 over 3. So your answer is still, you get 1 over 3. So, but this one in real analysis, they didn't say you must do it. So they just want to see if you know that when you work with an integral like this, is exactly equals to the limit. So that one, they just wanted to see that. So this conclude our proof, or the answer of the questions that we just did now. So at least we got 1 over 3. So exactly the same way, that I've written to you, you must write it this way. Some of the students, when they do it, you will find that they are going to use the n. If you use n minus 1, sum of n, sum of I mean in your summation, I mean when you check to the answers, some of the questions, I equals to 1. Then when we substitute there, you are going to substitute for f of x, for u, for L of P, U of Pn, you will have to substitute this equation. You will have to substitute I squared over n squared. So you can prove that it's still gonna give you the same answers, but don't use this method. Just use the one that I have just shown you. So do you have any question?
No questions.
No questions. Okay. So this is exactly how you answer that question. So when it comes to question number 4, I try to check it. So I'm gonna discuss it with you. We're still gonna have a class tomorrow. So for this one, I will discuss. There is something that I want to check properly before we go with that with this question. There is something that I was checking, but what happens when they state why the following integral is improper and find the value of the integral if it converges. So the first thing that we're going to check there, we'll have to check these equations, this inside there. We're going to let me just do it, but I'm not doing it properly. There is something that I really want to make sure that I prove before we discuss it together for a final. So, but let me just show you the steps that we need to take in order for us to answer this question. So in that integral there, we have, it's in I equals to, okay, I just want this one there is 2x over x squared minus 4 is 2x. Our I was equals to integral of 2. Okay, let me just check again. Yeah, 2x over in brackets x squared minus 4 x squared minus 4 over 2 over 3 2 over 3 and 2 to 6. So in this one, the first thing, let's read the question. These are the steps that you need to follow. State why the following, okay, following integral is improper and find the value of the integral if it converges. So the first thing that we're gonna do there, we are going to check, in order for us to check the convergence, we are going to say, we're going to say we let our an is equals to, we change this instead of x, we're going to say 2n over, in brackets, n squared minus 4 to the power 3 over 2. So when we have done that, then this is just a rough, we're going to call it rough work. So when we have done this way, if something converges, it must have a limit when it approaches something. So we're going to find the limit when n approaches infinity of an, then this is going to be equals to limit when n approaches infinity of 2n over n squared minus 4 to the power 3 over 2. Then when we do this one, now remember, this is the same as a square root of, we can write this as limit, the same as limit when n approaches infinity of 2n over square root of n squared minus 4 to the powers cubic. So this is the same as that. So now when we have written that way, we can now say, okay, in order for us to find this limit, what can we do? We can divide by n squared. When we divide everything by n squared, we are going to have limit when n approaches infinity of 2. When we divide this one by n squared, it's going to say 2 over square root of, inside the square root when you divide, because it's a square root, remember, square root of 4n squared at the power 4 is equals to n squared. So which means we divide everything. When we are inside the square root, you must divide. When we are saying we are dividing by 2, you divide by n to the power 4, which is the same as this. So we're going to divide everything by n to the power 4. When we divide by, if I don't divide by n to the power 4, I divide by, okay, yeah. If I divide square root of 2n squared, is going to be equals to n. So if I divide by n, I'm going to only divide by n, I'm going to get 2. Then inside here, the square root, I'm going to divide by n squared. Then it's going to say, when we divide by n squared, and remember the other thing here, when we divide by this n squared, we have a problem now because our n squared minus 3 is cubic there. When it's cubic, when our n squared minus 3 is cubic, the problem part that is going to happen is that if I have to get inside here and divide everything inside the cubic, it's going to be, that's when I want to verify what will happen, or is it does not sound right. So the other step, that's where I have a problem. So I know that this is the steps that we're going to use, but when this cubic here, I have to check what is the problem. So the other method that we can still use, which I also want to make sure if it's allowed in real analysis, I will check that for you, is when we are in this one here, we can use the L hospitality, L hospital. So L hospital, it states that we differentiate the whole equation. So when we differentiate the whole equation, it's going to be limit when n approaches infinity of this, we differentiate 2n, is going to be 2 over, when we differentiate this one, we are going to take 3 over 2 down, then n squared minus 4, and then 3 over 2 you subtract by 1, we're going to have 1 over 2. And we differentiate what is inside this equation. We're going to find that when we differentiate this one, is going to be 2n. So this, now when we simplify, you will see that this one is going to be equals to limit when n approaches infinity of 2 over this 2 here, it will cancel with this one. Then we're going to remain with 3n, this n times 3, the 3n in brackets n squared minus 4, whereby we can write this as limit as n approaches infinity of 3, 2 over, we multiply what is inside there is 3n cubic minus 4, which is 4 times 3 is going to be 12. Will be 12n. So now we have that. So now when we have this one, we can divide by everything by n cubic. So when we divide everything by n cubic, we'll have limit when n approaches infinity of 2 over n cubic divide by 3 plus 12n squared. So if we substitute 0 in this one here, we're going to see that is going to have 0 over 3 plus 0, which is exactly equals to 0. So now we have, just by using this is L, we call it L, hospital, hospitality. So this one here is we get 0, which proves that this function it converges. But now the problem with me is that normally in real analysis, we must go with this method of dividing. You see the way that method of not differentiating. When we get here, we can just try by all means to divide by n so that we don't do that. So now when we have that, so I have to, in that one, that's why I say to you, I will have to work it out properly and see when I'm alone and see what's going to happen. So this is the other way. So now we have done a little bit of something. In the same equation, we can also, there is something that I'm going to give you an idea. So when we're working question number 5, we proved that integral of 2 to 3 to 0 to 1 of x squared was equals to limit when n approaches that. So we are going to read the question again. So understanding of the question is very important. So this question says, state why the following integral is improper. So we have an answer why this is an improper. And again, it says, find the value of the what? Integral if it converges. We just prove that this can converge. We have found the value of an integral or if it converges. So now what we can also do, we can take this limit. So when we want to find this integral, the value of this integral, the other thing you will see that the partition, this is in between 2 to what? To 6. So now if it's starting from 2 to 6, then what is the partition of this integral? We can get p of n. When we get our p of n, you're going to see that's going to be 2. We can say 2, 4, or instead there 2, 4, 6, whereby we can rewrite it as 2, or we can say 2, 3, 4, 5, and 6. So we can write this as 2, then 1 over 3, 1 over is 2, 1 over n. Okay, 1, 0 to 1. We can, okay, we want to find a way that if we divide it, how we can divide it. Okay, I think this one here, when we divide it, we have to divide it by 2. We can divide it by 2. So if we divide it by 2, we're going to have 1 over 3. So which means 2, 6 divided by 3 is going to give us 2. So which means it's going to be, we can write it as 2.3 over n into 4 over n. Yeah, it's fine. Then 5 over n and 6 and 6. So it's still fine with this way. So now when we have done that, we will see that if we have to make the change in x, our change in x here, is it going to be 1 over n? Like you see this one here, we have divided everything 0 to 1. We have divided it by n. When you say 1 over, if you say 1 over n minus 0, you'll get 1 over n. And if you say 2 over n in this one here, minus 1 over n, you will see that you have n. 2 minus 1 is 1. So what about this one we just did there? If you say 2 minus 3 over n, you will see that this answer here, if we multiply, it's going to be 2n minus 3 over n. You see, the change is this one here. And then it's 2n minus 3 over n. Let's check if we can get the same change from 4n. If you say 4 over n minus 3 over n, then is n here. The changes here is going to be 4 minus 1. It's going to be 1, which is false. So which means this interval, the partition is wrong. Our partition is wrong. So when our partition is wrong, what we're going to do, we're gonna check it. So when I say checking it, we say if I divide is 2, then what if I say it's gonna be 2, 4, 2, 4, 6? Then we can say we are going to divide it by 4n here. So 4 over n. So if it's 4 over n, comma, then it's gonna be 6. So let's check what will happen if we are dividing it by 4 over n. So if we say 2 minus 4 over n, then this is going to say 2n minus 4, going to be 2n minus 4 over n. Then what if I say 6 minus 4 over n? Then this is going to be 6n minus 4 over n. You can see that we are not really getting the same interval. So I will have to work out so that I can get, if I have my f of x, which is this equation, which is going to be this one, then I can work the interval in this 2 to 3, 6. I will have to work the interval whereby I can get the p of n. After finding p of n, I will, when I get this interval, I'm going to use the same method that we're using to get u only L of p. We can check, I can check L of p and u of p. If they are the same, I know that is integrable. Then I can use only L of p. Then I know that the results for this is going to be what? Exactly that one. So answering it in terms of a real analysis. So those are the method that I'm gonna try to use them. So, but I'm gonna answer it just that I want to see, I want to check properly which one is gonna be the best. Then that's why I said we're gonna discuss it tomorrow. So, do you have any question?
No. Aren't we doing
Okay.
something else tomorrow?
If we are doing something else tomorrow, it means that I'm gonna just write it in a paper. I'll just send you in a paper so that you can see how it is done. Because we are only left with one question here. Unless otherwise, if you're gonna need an explanation, then which means we're gonna do it a little bit for installation, then we go to another module. So tomorrow, I think we are doing some, I'm not sure if it's MES 3706.
It's 3706.
Yes, yes, yes. Unless that's which means we can take 10 minutes for explanation. Then we proceed with this one for tomorrow. Then I'm gonna add 10 minutes for this question.
Okay, we can do that.
Yes, yes. So did you check what we did yesterday?
I have to check it.
You
I
have,
never
I know,
downloaded.
oh, you haven't done. Oh, okay, no problem. Then which means even this video is gonna be there. Then I don't know if you don't have any question, then we'll proceed tomorrow. Or unless otherwise, if you have something to say.
No, nothing else.
All right. Yeah, the video, I stopped the video. Then you can download the video and check them. Then the answer, the way it is there, it's exactly how you must write them. But just wait for me to confirm with question number 4.